Hi everyone! In this video, we show how to run an instrumental variable model using the graphical user interface and the dataset provided in the GitHub repository. In this example, we use the dataset 6institutions.csv to illustrate how the model works. First, go to the Multivariate section and click on Instrumental Variable. Then click on Browse and select the dataset named 6institutions.csv from the Data App folder. Once it loads, set the number of MCMC iterations, along with the burn-in size and the thinning parameter. You will also see a preview of the data and all included variables. The dataset should be organized as follows. First, the main response variable. Second, the endogenous regressor. Third, the set of instruments for the first stage equation, and finally, the set of exogenous regressors for the main equation. After that, specify the main equation using the standard R formula structure. Keep in mind that the first regressor should be the endogenous variable, followed by the exogenous regressors. Then specify the first stage equation, also using the R formula structure. In this case, the dependent variable is the endogenous regressor from the main equation, followed only by the instruments. Do not include the exogenous regressors from the main equation in the first stage. You can then modify the prior mean and the variance-covariance matrix of the location parameters for both the main and first stage equations. You can also set the degrees of freedom for the inverse Wishart distribution, along with the scale matrix of the stochastic errors. Once these settings are defined, click Go. The app will generate posterior summaries of the model parameters. First, you will see the summary of the posterior draws for the coefficient of the endogenous regressor in the main equation, along with its convergence diagnostics. Next, the app displays the posterior summaries and convergence diagnostics for the first stage equation. Then it shows the posterior summaries for the exogenous regressors in the main equation, together with their convergence diagnostics. Finally, the app provides summary statistics for the covariance matrix of the stochastic errors, along with the corresponding convergence diagnostics. You can also download the posterior chains as a CSV file and export the graphs as PDF or .eps files. I hope this video was helpful. Thanks for watching.